Hello students, and welcome back to another lovely day of physical science. In today's lesson we are going to learn about dimensional analysis. And it is a fantastic day because this is possibly the most important concept you will learn in this class. With it, I know dimensional analysis sounds scary. It's really not, and it's incredibly useful, not for this class, but when you get to chemistry, when you get to physics, and honestly you can actually use it in life, which we'll learn later on as we continue through the course. There's just a lot of value in being able to do this because it allows you to convert pretty much anything. So let's go ahead and get started because I know you're super excited. So learning outcome for this unit, I will be able to convert between English and metric units using dimensional analysis. So we're going to learn how to convert from things like, English units would be inches, feet, miles, yards, or pounds and ounces and things like that. Metric units are going to be more like centimeters, meters, grams, kilograms. And that's what we're going to learn how to convert today, is from one to the other. But before we do that, we need a little background knowledge. Using your already fantastic math skills, I want you to please pause the video and try and solve this question on your own. Okay, now that you've had a chance to try this, let's actually go through and solve it. What some students do here is they take, 5 times 3 is 15, divided by 3 times 7 is 21, so you get 15 over 21. You're not wrong, but there's actually an easier way to do this. The way that I would solve for this is a 3 on top is going to cancel out a 3 on bottom. Because 3 divided by 3 is just 1, and when you multiply by 1, nothing happens. So really the easiest answer here, 5 over 7. Just a nice simple shortcut to get that. And it's the same thing as 15 over 21, but it's actually reduced, which you should always do. So simple answer, 5 divided by 7. Okay, well, let's try this concept again. Please pause the video and try this question on your own. All right, now that you've had a chance to try this, let's just keep using that shortcut. Since I have a 9 on top, and a 9 on bottom, I'm just going to cancel them out. Same thing, since I have 13 on top and 13 on bottom, I'm just going to cancel them out. And what do we have left? We have 7 on top divided by 3 on bottom, so we get an answer of 7 over 3. Nice simple way of doing these types of problems. Oh, man, you look at this and you're like, oof, that's a doozy. I believe in you. Please pause the video and try this one on your own. All right, now that you've had a chance to try this one, let's go through and solve for it using our shortcut. 15 on top, and again, they don't have to be right by each other since these are all multiplied here. It doesn't matter where on top or where on bottom they are. So I have 15 on top, I'm just going to cancel out the 15 on bottom. It doesn't matter that it's all the way over here. Or I have 23 on top, 23 on bottom. They can cancel out. All right, I have a 68 and a 68. I have 121. I have 121. I have a 1389. I have a 1389. Who knew that after all of this, we'd have a nice simple answer of 3 over 7. Really, these aren't bad. Dimensional analysis is basically just taking this skill, instead of just applying the numbers, we're going to apply it with some other stuff too. So I would like you to please pause the video and try this question on your own. All right, now that you've had a chance to try this, hopefully you realize the concept is the same. I have x on top and I have x on bottom, so they're going to cancel out. I have y on top, y on bottom. They're going to cancel out, and you are left with just this beautiful answer of z over w. There you go. So it doesn't apply with just numbers. That skill that you've learned before, that you just learned, applies with really everything. What you're going to do is this idea of canceling stuff out or crossing stuff off is what we call dimensional analysis. You have to write out your work. I cannot stress this enough. Yes, you will get better at doing this process. I understand that. But I will tell you, really the only reason students make mistakes on this, well, not the only reason, but the main reason students make mistakes on this is because they try skipping steps. I understand you're excited and you want to get to the final answer, but please slow down in these problems. It's not worth saving 30 seconds of your time to get an incorrect answer. Take the extra time, write stuff out, and ensure you get the correct answer, because really this same process applies to any one of these problems. And if you follow that process that I'm going to show you, you can guarantee yourself to get a right answer every time. So seriously, slow down with these problems. I know some of these first ones I show you in this set of notes are going to seem a little basic. There's a reason. It's a learning process. We are going to ramp things up very, very quickly in upcoming notes. So let's go ahead and get started. Let's say we want to convert 15 feet into inches. Again, I realize some of you can do this in your head right now, or you know how to solve for this. But I want to show you the actual process for doing this and why that works, so that way you can apply it to any sort of situation. So first thing we're going to do is we are going to look at that equation sheet that you have, or that conversion sheet. And down here, you're going to see this conversion. You know you want to go from feet into inches. So you need to find conversion from feet to inches, and hey, we have one. 12 inches is equal to 1 foot. Cool. So what we want to do now is write out a path. Our path is just going to be from feet into inches. And then for every arrow, not all of your paths are going to be just one step. Again, we're just introducing this. For every arrow is one conversion that you're going to need. So we know we're going to need one conversion, and that conversion is 12 inches is equal to 1 foot. Or, again, with the equals, you can write it either way. So I can say 12 inches equals 1 foot, or I could say 1 foot equals 12 inches. These are the exact same thing. I'm just changing the way that I write it. It really doesn't matter. Okay, then what we're going to do when we solve these problems is you take what's given to you, that is what you're trying to convert, and you're going to bring that down here. And then I like to build what I call this our railroad tracks. Every dimensional analysis problem, you're going to start with railroad tracks that look essentially like this. So you're going to bring what's given down, and you're going to write that in the upper left-hand corner. Then all you're ever doing for your conversions, or for these additional sets of tracks, is you're bringing in these conversions. Down here below this, for now you will not write anything below. What you would do is if you had like 15 feet per second or something, the seconds would go on bottom. But again, you'll see that in upcoming units. So right now what we want to do is we want to remember the process that you just did of canceling out. That is, we have feet in our given right now. We don't want feet in our final answer. We need to get rid of feet. Well, how do we do that? We have to cancel it out. So if feet are on top, how do we get them to cancel out? Well, we need to put feet on bottom. And looking at our conversion, we see that 1 foot is equal to 12 inches. So what I'm going to do, I'm going to put 1 foot on bottom. I'm going to put 12 inches on top. And what that does now is just like you saw in the previous slides, feet on top can cancel out feet on bottom. Notice the numbers don't cancel out because they're not the same. 15 does not cancel out the 1, but feet cancels out feet. And you'll also notice all we did was bring in that conversion. I'm just saying 1 foot is equal to 12 inches. That's true. So we can do that. Well, that's it. We wanted to get into inches, and that's all we have left. Inches are the only unit we have left. We did it. We've just solved our first dimensional analysis problem. So what we're going to do now is we just take everything on top and multiply it. So we're going to take 15 times 12 inches. And then realistically, we could divide by 1, but dividing by 1 is nothing. And there you go. You now know that 15 feet is equal to 180 inches. And you can see the entire process for doing so. Well, let's try this again, and we'll speed things up a little bit because we don't need all of this explanation. Or for those of you that are feeling confident, what I would like you to do, please pause the video and try this problem on your own. All right, now that you have had a chance to try this, I will tell you that the correct answer is 3.53 ounces. If you got that, fantastic. You can fast forward ahead. If you didn't, I'm not surprised. Like, you're just learning this process. So let's go through and solve for this. What you would do is, we know we want to go from 100 grams and convert it into ounces. Well, looking at our sheet down here, we see this conversion. 28.35 grams is equal to 1 ounce. Cool. I have a path that goes straight from grams into ounces. So again, I only need one conversion in order to do this. And I like to write my conversions off to the side here, so we can say that one conversion that we need, I can say 28.35 grams is equal to 1 ounce. Or again, I can write this the other way and say 1 ounce equals 28.35 grams. It doesn't matter. They're the exact same thing. It's just a preference of how you want to write it. Then what we need to do, we're going to go through and build our railroad tracks. So I'm going to get that whole process started. And again, whatever you want to solve for, or whatever you want to convert, is what goes in this upper left-hand corner. Again, we don't write anything on bottom. And now what we're going to do is start bringing in that conversion. But you have to ask yourself, what goes on top, what goes on bottom? Again, we don't want grams in our final answer. We need to cancel out grams and get it to ounces. So what's going to happen? We have to put 28.35 grams on bottom. And 28.35 grams is equal to 1 ounce. Well, grams on top cancels out grams on bottom. And look at that. We had a goal of ounces, and that's all we have left for units. So life is good. Now what we're going to do is we multiply everything on top. So 100 times 1 ounce divided by, and all we have left on bottom is 28.35. There's no units. There's nothing like that. So we're just going to divide by 28.35, and that is how we get our final answer of 3.53 ounces. All right. Hopefully you're feeling a little bit more confident with this. But let's go through and just do one more practice problem for these introductory notes. And we're going to up the challenge just a little bit. For those of you feeling confident, I would like you to please pause the video and try this problem out on your own, and I will show you the answer in a few seconds. All right, now that you have had a chance to try this out, 50 inches is going to be equal to 1,270 millimeters. If you got that, nice work. You are done with this video lesson. You can move on. If you didn't, again, I get it. This stuff is tough. Let's go through and see how we solve for this. First thing, we need to figure out a path. Again, do not try skipping steps. You need to do this in order. So we need a path to get us from inches into millimeters. And looking at your conversion sheet, you'll notice you don't have a conversion going straight from inches to millimeters here. This is going to take a couple steps. So you have to think your way through this a little bit. Well, okay, I can't convert inches into millimeters. Well, so what can I convert inches into? And here you see 1 inch is equal to 2.54 centimeters. Well, yeah, that's getting you closer. Okay, so 1 inch is equal to 2.54 centimeters. So do I have a way to get from centimeters to millimeters? Yeah, you do. 1 centimeter equals 10 millimeters. There's your path. So now your path, you're going to convert inches into centimeters and then centimeters into millimeters. And notice, now we have 2 arrows. So we're going to need 1, 2 conversions. Okay, well, our first conversion was down here. So to get from inches to centimeters, we use the conversion that 2.54 centimeters equals 1 inch. Then we need a second conversion. We need to get from centimeters into millimeters. So our second conversion was down here, and it was that 1 centimeter equals 10 millimeters. Again, it doesn't matter how you write this. I could have written 1 inch equals 2.54 centimeters. They're the same thing. Fantastic. We're off to a good start. Now that we have our conversions and we have our path, we can start building our railroad tracks. So with that, I'm going to bring down the 50 inches. Since I have inches on top, I have to put inches on bottom. And again, all you're doing is bringing these conversions in. And a cool trick, this first conversion is going to be your first set of railroad tracks. So I know my first conversion goes right here. And I know that 1 inch equals 2.54 centimeters. Since I have inches on top, inches has to go on bottom. And 1 inch is equal to 2.54 centimeters. Inches on top cancels out inches on bottom. And now if we stopped right here, we'd be in terms of centimeters. That's not what we want. We want to get to millimeters. So we have to add on a second set of railroad tracks. And guess what? All you're doing is bringing in your second conversion. And you ask yourself, since I have centimeters on top that I need to get rid of, I have to put centimeters on bottom. 1 centimeter is equal to 10 millimeters. So centimeters on top cancels out centimeters on bottom. Boom. Look at that. We wanted to get to millimeters. We got to millimeters. So now all we're going to do is take everything on top and multiply it. So you're going to get 50 times 2.54 times 10 millimeters divided by, and I guess, 1 times 1, which is just whatever. And there you go. 50 times 2.54 times 10 millimeters gives you that answer of 1,270 millimeters. Congratulations. You just learned how to do dimensional analysis. But let's ramp this up a little bit. I would like you to please continue on to the next set of notes.